This skill module covers pumps and compressors at the core knowledge level. This section discusses why this topic is important. Selecting the wrong pump for an application can result in the pump not being able to perform or meet the required process conditions, or it could result in lack of efficiency in terms of power use by selecting a pump that is much too large for what the process requires. A pump selection chart is provided that shows how the best pump type can be selected based upon the process head and flow requirements. Understanding the relationship between pump head and differential pressure is required for pump selection or for troubleshooting a pump that is running in the field. Understanding how to estimate the pump power for a given application is important to ensure that the driver selected or available has the power required for the application. In addition, this module will provide insight into how centrifugal pumps create head by converting kinetic energy to potential energy. This allows engineers to better appreciate how to change the performance of their centrifugal pump by changing out the size of the impeller when they need to debottleneck the plant and increase plant capacity. Centrifugal pumps can be thought of as variable flow, constant head devices. Positive displacement pumps, on the other hand, can be thought of as constant flow, fixed volume, infinite head devices. Understanding the performance differences from the two types of pumps is required to choose the right pump for a given application. This skill module discusses the primary differences in performance and operation of centrifugal pumps and positive displacement pumps. Understanding the differences between their performance in an operation can help one decide which type of pump is the best for a given process application. Understanding these terms and how to estimate them: cavitation, net positive suction head required, NPSHR, net positive suction head available, NPSHA, and the fact that NPSHA must be greater than NPSHR, will prevent severe damage to pumps operating in the field. Plunger pumps are probably the most common positive displacement pump used in process applications. Understanding how they operate, how to mitigate pulsating flow variations, and other important installation details is important to ensure that they are selected and installed in the field properly. Understanding the principles of operation of centrifugal pumps is important for both pump selection and troubleshooting. The centrifugal pump curve needs to be selected such that it is a good match for the piping system curve in which it will be installed. Understanding how to read the pump curve is required to determine where the pump will be operating under normal operating conditions, as well as confirming the net positive suction head required for that condition. If a pump is selected for an application that has insufficient net positive suction head available, then the pump will continually be running in cavitation, resulting in increased maintenance costs due to excessive wear. In addition, the pump curve can be used to give insight into pump component health. If the pump discharge pressure is lower than what the pump head curve indicates, then that could be an indication of increased internal leakage. That could be caused from wear ring wear or labyrinth seal damage between impellers in multi-stage pumps. Compressor head is directly proportional to the compression ratio of a compressor. The compressor power is directly proportional to the compressor head. The estimated discharge temperature of a compressor is directly proportional to the compression ratio of the compressor. Understanding these key relationships is an important first step in understanding what parameters will affect the compressor performance. Gas compressors typically have the largest power requirement out of all of the equipment in a gas processing facility. Understanding the variables that impact compressor power is important as a result. There are practical limits to compressor discharge temperature that are important to understand for compressor selection and operation. Understanding centrifugal compressor performance curves and their capacity control is important if you are selecting a compressor for a new process application or if you are trying to optimize the operations of an existing compressor in the field. In addition, understanding the machine limits of operation defined by the surge line, stone wall, and installed driver power is critical for safe and reliable operations. Reciprocating compressors are often the compressor of choice for onshore gas gathering systems. They are relatively insensitive to inlet gas conditions such as temperature, pressure, and molecular weight. Understanding the principle of operation of these machines is important if you have these running in your gathering system or gas processing facility. There are 5 capacity control operations for reciprocating machines. 1. Speed. 2. Clearance volume. 3. Valve unloading. 4. Suction pressure throttling. And 5. Recycling. This module will review and discuss the primary operating limits of the machine and will cover all 5 capacity control operations in detail. Rotary screw compressors can be thought of as constant volume variable head machine. The flow rate through this positive displacement machine is constant rather than pulsating as compared to reciprocating compressors. These compressors compress gas differently than both the reciprocating compressors and centrifugal compressors. Thus, their performance characteristics, compressor components, and primary principles of the operations are different. This module discusses rotary screw compressors, both dry and oil-flooded. Their performance characteristics, main compressor components, and primary principles of their operations are covered. This skill module discusses the topics shown here. You may also be interested in these gas conditioning and processing principles skill modules.